Bob Bird began his technical education at the University of Maryland, and then interrupted by a tour of duty in the military in Europe during World War II, then eventually returned and resumed his technical education at the University of Illinois, where he obtained his bachelor's degree in chemical engineering. He then proceeded to graduate school in physical chemistry at the University of Wisconsin-Madison, working for Joe Hirschfelder. And while a graduate student, Dr. Bird was invited by Dr. Hirschfelder to help write the book, Molecular Theory of Gases and Liquids. That book was completed in 1952 and was a very significant compilation of the theoretical principles governing transport properties. Immediately after that book was submitted, he began a position as an assistant professor of chemistry at Cornell University. But within a year's time, the University of Wisconsin lured him away to chemical engineering on the campus of University of Wisconsin-Madison. After a short 4 years on that campus, Dr. Bird was asked to create a course entitled Transport Phenomena for the curriculum in chemical engineering at the University of Wisconsin, to be taught that fall. 2 other faculty members, equally young in the department, Dr. Warren Stewart and Dr. Ed Lightfoot, agreed to and volunteered to help with the project. The result eventually was the publication in 1960 of the signal textbook, Transport Phenomena. That book has now undergone 62 printings and is in its 2nd edition. That signal work provided a framework to unify and correlate many apparently diverse aspects of momentum, mass, and energy transport, and changed forever the way we view and describe those phenomena. Dr. Bird's research, much of his research is focused on polymers since the publication of that book, and he wrote 2 volumes on the dynamics of polymer liquids, which were very important publications. But Bob's scholarship and authorship go beyond the technical. He's been a historian, authored the publication about the first 100 years of chemical engineering at the University of Wisconsin. He's also been a student of languages. Very early on, he learned to speak German and French, which actually was quite a benefit during World War II. But he then went on to learn the Dutch language. And recognizing that there was not a sufficient book, a literary book for those learning Dutch, he wrote 2 of them. Then he went on to learn Japanese and recognized that there wasn't a good book on technical Japanese, so he wrote 2 of those, along with another book on Japanese numbers. Dr. Bird is an avid genealogist, by the way. He's published 4 books of family history, 1 for each of his grandparents' lines, and just donated today or yesterday, I don't know which, to the LDS Family History Library, the 2nd edition of 1 of those books. He's been a student of music, both the piano and the organ. He's been an avid canoeist, and over a lifetime, he estimates 75 canoe trips, 2 weeks apiece, mostly in Canada. Always learning, always writing, still going strong at 85 years young. We're grateful, Bob, for your life. Honored that you would accept the invitation to be the Reed M. Izatt and James J. Christensen Lecturer. Thank you for being here.
Thank you. Thank you, Ken, for an overly complete introduction, but I am glad that you included the bit about the canoe trips. Can you hear me okay in the back row? Raise your hands if, the hands all went up, I think. Well, I'm going to start out by telling you a little secret. When I was a high school student, the two subjects that I disliked the most were English and history. Later on, I began to realize that this was a big mistake. When I got to Europe in 1950 to participate in a Fulbright grant in the Netherlands, I did a fair amount of traveling around Europe, and I'd go to various museums and people would talk about the Napoleonic Wars and the 100 Years' War. I didn't know when those took place or who was involved. And then later when I went to China, people talked about, well, this happened in the Tang Dynasty. I had no idea, no clue when the Tang Dynasty was. Well, after I retired in 1992, I started to read. And first I read fiction, and then I read all the mystery stories of Dorothy Sayers, because I like those. And then a lot of P.D. James mystery stories. But I found that the books that I really liked the best and really gave me more new ideas were biographies and autobiographies, because these deal with real people, not with fictional detectives. So tonight I'm going to talk about a handful of people whom I have come to know through reading biographies and autobiographies. In each case, I'll try to tell you what inspired them. I'll try to tell you what obstacles they had to overcome and what sorts of driving force there was which caused them to have such unusual achievements. Now, each one of these will be a little vignette, as it were. And the first one deals with Lewis and Clark. I bet you don't associate them with science, but you're wrong. Actually, Thomas Jefferson was as much a part of the Lewis and Clark event because he wanted this group of people who went out to the West Coast to achieve certain objects. And these involved botany, zoology, geography, cartography, ethnology, and linguistics. As some of you know, Thomas Jefferson was quite a bright fellow, and he inspired greatness in the Lewis and Clark group. The best book you can read about that is Undaunted Courage by Stephen Ambrose, which I've listed here on this slide. Now, the first question you might ask, was this group of Lewis and Clark just a bunch of real tough guys, or were they really the core of discovery that Thomas Jefferson imagined? How many people survived the expedition? Turned out all but one survived, and he got appendicitis. And then finally, who was Sacagawea of the dollar coin? I presume all of you know what this coin looks like, and I brought one along in case anybody hasn't seen it. However, you will be checked with a metal detector when you leave the room. Sacagawea was actually the wife of Charbonneau, who was a French-Canadian. And so when they got into various Indian tribes, Sacagawea would translate for her husband into French. And then he would translate he would talk to another fellow named Drouillard who spoke English and French, and then it would be translated into English for Lewis and Clark. So you can imagine that there were a lot of misunderstandings. Here are Lewis and Clark. Now here's what the United States looked like in 1803, in case you've forgotten. The United States went up to the Mississippi River. You know what the population was then of the whole country? 5 million. What is it today? 250 million? Then France owned the Louisiana Purchase, the white part here, and then all the southwest was under control of Spain, and then of course we had Texas, and then up here in the north we had Great Britain, and of course Alaska was owned by Russia. Now here's what was involved in the Lewis and Clark expedition. Lewis started out from Pittsburgh, and he bought a keel boat there. It was 50 feet long, and he started down this river, and along the way he would enlist people for his trip from among the various army posts. And then when he got down to St. Louis, by that time he had a pretty complete crew. And that's where they stayed in the winter of 03 and 04. By 1804 and 1805, they were way up in North Dakota with the Mandan Indians. Now keep in mind that they had to canoe up the Missouri River all the way to the Idaho border. Have you ever canoed upstream against a 5-mile-an-hour current? Let's see the hands of all those who have. 1, okay. You must be a pretty tough guy. Well, yeah, I've canoed upstream on the Wisconsin River, and believe me, it's hard work. Anyway, the 1,400 some miles up the river. Then up here they had to cross the Rocky Mountains and then go down the Columbia River on the far side. And then they spent their second winter over here on the Oregon side of the Columbia River. Then the following year, they picked up, broke camp, and came all the way back to St. Louis. Of course, that was downstream. That was just sheer fun. Okay. Now, one thing you might not know is that Lewis actually lived in the presidential mansion in Washington, D.C. and for 2 years. Jefferson's wife had died and his daughters had moved out, and so Jefferson said, "Hey, look, I got all these rooms here. Pick a room and move in," which he did. And then the two of them sort of planned this trip out to the Pacific Ocean. Then Jefferson sent Lewis up to Philadelphia to learn how to be a doctor. He was going to have to take care of his men on this trip. And Jefferson wanted to know everything about plants, animals, tribes, tribal languages, and so forth. He also wanted to know exactly what the longitude and latitude was of the confluences of the rivers. Incidentally, he was elected to membership in the American Philosophical Society, which was in recognition of his scholarly attainments. Thomas Jefferson's vision was a United States that went from ocean to ocean. And of course that shaped our future. Now, Jefferson took copious notes along the way. Here's one page from his notes describing the canoes. The next one here describes a couple of birds and a fish. And the last page I have of his diary here is a description of another fish. So he really was satisfying Jefferson's wish. Now the next vignette will concern Isabella Lucy Bird. Now she's not a relative of mine as far as I know. I've done the family genealogy back to 1700 and I didn't come across her, unfortunately. She was a very, very brave and interesting woman. And her main contribution was to the geography and the ethnology of Japan. She was a preacher's daughter. And why on earth would she go and take this rough trip up through Japan? Actually, this trip plus a dozen others like it entitled her to be a member, the first woman member of the Royal Geographical Society. She was hospitably received by the Japanese natives and also by the Ainu who live up in the northern part of the country. She took an interpreter along who was 18 years old. Here she is. That's Isabella Lucy Bird. Doesn't she look like a sort of a staid English woman? Yes. Now, Japan was opened to the Western world in 1868, and she started out from Edo, which was the name for Tokyo at that time. Then she traveled by foot and in a kuruma, I have a picture of that, in boats and on pack horses. She went clear up to Ezo, which is Hokkaido. She stayed in little tiny towns in very, very primitive inns, which were usually infested with mosquitoes, fleas, and ticks. The other thing was, I don't know how much you know about Japanese houses, but they don't have walls like we know. They have sliding panels with wooden strips like this, and then they're covered over with paper. Well, when she would get ready to go to bed at night, she would hear people poking holes through the paper and the doors, and then behind each hole, she would see an eyeball. You can imagine that this would be rather disconcerting to an English lady. Well, her travels lasted 7 months. She's a terrific writer. She gave very detailed discussions of what she saw. And what really amazed me was the choice of color words that she had. I mean, most guys like me know red, blue, green, and that's about it. Women, on the other hand, can tell you the difference between puce, beige, and mauve. Isn't that true? How about that? So there's a big difference between men and women. Now, if you like this story, which I did very much, you'll also like The Lady's Life in the Rocky Mountains. That's the one where she ran out of money and had to spend another winter in the Rocky Mountains, and she found that the only thing she could do was go up and stay with a one-eyed crook, a guy who was wanted by the police. But she said, if you'll bring in the meat, I'll keep your place nice and clean. Okay, here's Isabella's trip. She started down here in Yokohama, Tokyo, then she went to Niigata, then right up along the mountainous ridge of Japan. Then she took a ferry boat over to the island of Hokkaido. Then she traveled up and down there, and that's where she met the Ainu. Okay, now here you have a kuruma. I told you part of her trip she went by means of a kuruma. Actually, today the word kuruma means an ordinary automobile or a taxi cab, but this is what she rode in part of the time. This is the pack horse that she had to ride. And you'll notice that this has got a contraption up here of rope and wood. I imagine that was most uncomfortable to sit on. But nonetheless, that's how she went on part of her trip. Here are some Ainu. I told you they were different from the Japanese. You know, Japanese don't have much facial hair, but the Ainu had a lot of facial hair, and they also practiced tattooing. So there's an example of tattooing. So she's really a wonderful person to get to know. Now the next one are really my favorites, I guess. Wilbur and Orville Wright. There have been many biographies written about them. I've listed two here. And neither one of these boys had a high school diploma. Now, mind you, I'm not suggesting that you should drop out of high school so that you can become famous as an inventor. It just might not work for you. The first flight that they took, the first motorized flight that they took down at Kitty Hawk, North Carolina, lasted 12 seconds, and they went all of 120 feet. Think of that. Think of the progress that we've made during the past century. Now we go to the moon. But back then, that was the first motorized airplane flight. No, the Wright brothers were, their father was a bishop, and their first little enterprise was a printing press. They gave that up after a few years and started up a bicycle shop. And that bicycle shop had the address of 1005 West 3rd Street in Dayton, Ohio. And a few years later, that's exactly the address that was the ice cream factory of my grandfather. Can you imagine what it was like to be a child and have a grandfather who manufactured ice cream? Oh, marvelous. All my friends were jealous, very jealous. Well, they began to get interested in air travel or I should say in gliding, when Otto Lilienthal in Germany crashed in 1896 and was killed. So they started reading voraciously about the literature of gliding. And Wilbur came up with the idea of wing warping to gain stability when you were in a curve, because nobody had ever studied stability before, much to their surprise. Then in 1900, 1901, 1902, they trekked all the way down to Kitty Hawk, North Carolina, to test their ideas on gliders. They're in a nice sandy stretch of an island. Then they did, all their gliding experiments were failures, and they couldn't understand why they were failing. Finally, they decided that Otto Lilienthal's data that he had taken on drag and lift of airplane wings was no good at all. So that winter, they set up in their bicycle shop a wind tunnel, and they put in all kinds of wings and all kinds of orientations, and by golly, they completely redid these valuable tables. Then in 1903, they were able to fly with a motor. Now, the interesting thing is, you know, today so much of research is run with government money, not the Wright brothers. They earned every penny for their research, for the materials, and their travel from the income from their bicycle shop. So that was really quite a feat. Here's the record of their flights on December 17th, 1903. I already mentioned the first flight was 12 seconds. Wilbur took the second flight for 13. Orville went for 15. Finally, Wilbur went for 57 seconds and an amazing distance of 852 feet. Wow, all that in one day. Later, they did experiments at Huffman Prairie, which is just outside of Dayton, Ohio. And in 1940, they put up a monument to the Wright brothers overlooking Huffman Prairie. And my granddad said, you know, we have an invitation to go to that. Would you like to go with me? So I went with him out to Huffman Prairie, and my granddad introduced me to Orville Wright. So if you want to shake the hand that shook Orville Wright's, come up after the lecture. Well, the next thing was that they tried to sell their product. They wanted to sell the U.S. Army, and they wanted to sell the French people the airplane, the idea of using it. And so they gave demonstration flights at Fort Myer, Virginia for the U.S. Army, and Wilbur went over to France, and he gave demonstrations in France. That was in 1908, and by then Wilbur was able to do one flight that was 90 miles for 2 hours and 20 seconds. Then in 1927, there was Lindbergh's flight across the ocean. Now, some of you may not realize, but Charles Lindbergh was a dropout from the University of Wisconsin. Yes, he really was. He flunked just about everything except ROTC. But anyway, right after the flight, he flew to Dayton, Ohio, just so that he could shake the hand of Orville Wright, and they had a wonderful time. Here's the island on which they did their experiments. Here's the little mail station of Kitty Hawk. They could only go this far by train. Then they had to take an old rickety boat across here with all their materials there, so they could put the airplanes back together again. Neat, huh? Now let's see what we got next. Oh yes, here's the very first flight. This is the 12-second flight, and that's Orville lying prone on the lower wing, and that's Wilbur running along the side to catch him in case he crashed. That was in 1903. Then here we have Wilbur flying in France, and to great acclaim of the French people. And here's Orville up here demonstrating a flight in Virginia. And then the next slide we have Wilbur and Charles Lindbergh. Incidentally, if you want to read a very good book on Charles Lindbergh and his flight, you can try the book by Scott Berg, B-E-R-G. That's easy to remember, Lindbergh Berg. And it's a great book, and he had access to all the family papers. Okay, let's go on to Max Born. And now we're beginning to get into the modern era. He was one of the pioneers of quantum mechanics. Do you all know what quantum mechanics is? Well, What you learn in high school is Newtonian mechanics from 1678. But you can't apply that to the motion of electrons and atoms. For that you need a different kind of mechanics, and that's called quantum mechanics. Similarly, if you want to look at the motion of planets and stars and galaxies, you need a different type, still different type of mechanics, and that's relativistic mechanics. So these two great new theories blossomed in the 20th century and completely changed physics. Now, there were two main centers for quantum mechanics, both of them in Europe. There was Max Born in Göttingen in Germany, and there was Niels Bohr in Denmark. There was nothing going on in this country at that time at all. It was really a European subject. But he finally lost his professorship in Göttingen because he was from a Jewish family. And when Hitler came to power, all the Jews lost their jobs. I'll talk more about the Nobel Prize in the next slide. Now, what was his relation to the pop singer and actress Olivia Newton-John? Do you all know her? Olivia, she was famous for her role in a movie called Grease. I never saw the movie, but everybody tells me it's really famous. More famous than Max Born. Well, let's see. Max Born had everything in the way of education. He went to the best universities in Europe. And in 1913, he and his wife converted to Christianity. He was a gifted teacher, very good. But the thing that interests most everybody is the fact that he had among his assistants and students 7 people who got the Nobel Prize. I don't think anybody has ever equaled that. Now, and of course, these people are all awful famous. Fermi, who built the first nuclear power at the University of Chicago, Werner Heisenberg, who should have shared his Nobel Prize with Max Born in 1932, because Max Born really contributed to that work. Gerhard Herzberg, Wolfgang Pauli of Switzerland, Eugene Wigner, who was Joe Hirschfelder's major professor, and Oppenheimer, who did not get the Nobel Prize, but I think you all know what he did. Wigner I had a course from Wigner at the University of Wisconsin when he was teaching up there one summer. It was one of the most difficult courses I ever took because he faced the audience and wrote the equations with his finger in thin air. Can you imagine trying to decode equations that you see coming at you backwards? Horrible. Absolutely horrible. Well, and he was forced out of his position in 1933 and went to England and got British citizenship. And then he moved back to Germany. There's Max Born with his granddaughter, Olivia Newton-John. If you happen to be going to the doctor's this week or next week, you may find in the doctor's office a little brochure from one of the sort of popular medical journals, and it's about Olivia Newton-John, who's apparently done great things in connection with cancer in women. She's become very famous for this. Okay, let's go on to Emmy Noether. You probably have never heard of her, but she was a very eminent mathematician. You can read what Einstein had to say about her. She wanted to enroll in the University of Erlangen, but was not allowed to because she was a woman. And at that time, Germany didn't want women in the universities. The Herr Professoren in Germany said that would change the entire character of the university, so they couldn't get in. Then she went to Göttingen University, where she had applied for a professorship. They wouldn't accept her as a professor because they said, oh no, that would change the whole nature of the university. In 1933, she had to leave Göttingen because she was Jewish, and so she went over to Bryn Mawr. But after 2 years, she had to have major surgery, and she died as a result of that. She was nearsighted, unattractive, overweight, sloppily dressed. She was a sort of a tomboy. She was loud and raucous, but warm-hearted, friendly, and optimistic. She was very kind to her students. She led a number of students to their PhDs. She had many periods when she went without any salary, both in Göttingen and in Erlangen. Now, she's very famous, and what got me interested in her was Noether's theorem. And this is a very important theorem which shows how the conservation of energy, momentum, and angular momentum are related to the properties of space and time. So there's something very, very interesting here, which I only learned about 15 years ago, even though I'd been teaching these conservation laws for the 40 years before that. I might mention that Emmy has a crater on the moon named after her. Here she is. As you can see, she has kind of a friendly look, but you can't see how fat she is here or how sloppily dressed she is. But she was a wonderful person. Everybody loved her. Okay, the next one belongs to the modern period too, and this is Paul Dirac. There's been recently a wonderful biography written by Graham Farmiloe, and that's almost a must-reading for anybody who's in science. And then, of course, his own book called The Principles of Quantum Mechanics, which was first published in 1932, is still full of valuable things even today. I would say, and many other people would say, that the two most revolutionary and creative physicists of the 20th century were Albert Einstein and Paul Dirac. His most famous product was the Dirac equation, which you probably can't see here. That's all right, I will magnify it on the next slide. Now you want to know what is his relation to Cary Grant of Hollywood fame. See, I have to relate all these people to Hollywood somehow or other. Well, Cary Grant's original name was Archie Leach, and Archie Leach and Paul Dirac were in the same grade school in Bristol, England. Here's the famous Dirac equation, which describes the motion of an electron and its spin of an electron and its magnetic field. And that's really a very important equation. I'll say more about it in a moment. Now what you really have to understand about Dirac is what a miserable childhood he had. His father, who was from Switzerland, forced his sons every night to speak French at dinner time. And they hated it because the father was so very, very strict. If they'd make a little mistake in grammar, he'd just go into a rage. So please, parents, if you be nice to your kids, teach them foreign languages, but not the way they had to learn it. After grade school, he went to the Merchant Venturers Technical College, where he was filled with courses on shop work and technical drawing, stuff like that, which he was not very good at. Then he went to the University of Bristol and studied electrical engineering, not because he wanted to, but because his father wanted him to. Then he switched to applied math, where he got some encouragement finally for going further to Cambridge. In Cambridge, he plunged right into relativity and quantum mechanics. And he came up there with the idea of inventing the Dirac equation, which would satisfy both quantum mechanics and relativity. In the fall of 1927, he just isolated himself in his room at the university. He didn't go out except for meals. He just worked like a demon. But by Christmas time of 1927, he had that equation which I showed you. He was very happy, but he didn't tell anybody about it. He just published it in 1928, January. He didn't tell his parents about it either, particularly his father. Well, the next thing was that at first all the big physicists were dazzled by his performance. And Wigner, who the guy who wrote the equations in the air, Wigner was flabbergasted. He said, a 26-year-old guy did this? You know, nobody else can do this, but he did it. Well, then some of the big wheels began to notice, oh, there's something wrong with this equation. It also predicts that there will be a positive electron. You know, most electrons are negative. But this equation predicted a positive electron. That can't be right. So they just ignored him and his equation. And then out in Caltech, which in that direction, is that direction of Caltech? Huh? That's Caltech, okay. Over there in Caltech. No, you think it's this way. All right, a little bit south. All right. So over in Caltech, there was Carl Anderson, who was analyzing cosmic rays, and he was doing bubble chamber experiments. And he found a track of a particle which was positive, but otherwise had all the properties of an electron. Well, he told some of his colleagues about this. They said, boy, before you publish that, you better do the experiment again and again and again. Don't publish something you'll have to retract. So he did it again and again, and he still got the positive electron, which we now call positrons. And but the Caltech people, they didn't know anything about what was going on at Cambridge. The people at Cambridge, they didn't know anything about what was going on over in Caltech. But there was a professor at the University of Wisconsin in the math department named Rudolf Langer. And Rudolf Langer had been following both developments just because he enjoyed it. And when he pointed that out, then everybody was amazed, because Dirac's equation predicted the existence of the positron before it was ever seen. He got the Nobel Prize the next year at age 31. Fantastic story. It's really worth reading this book, because it just has you on the edge of your chair the whole time. Now, he had absolutely no social skills, probably because of his miserable childhood. He was a loner at Cambridge. He never went to any events. He just ignored everybody, very shy. And he was known for being very taciturn. People would ask him questions and he would say yes, no, yes, no, nothing more. But he ended up marrying Wegener's sister. That's the sister of the guy who wrote the equations in the air. Then in Cambridge, he was very happy for many years, and then George Batchelor came there as head of the department. And George Batchelor was real mean to Dirac. He didn't respect him at all. And finally, Batchelor left Cambridge, which he thought he would never do, and he retired to Florida State University. Next slide shows you Dirac on the left and Heisenberg on the right. Next. Now we come to the last one, which is a bit of a joke. You may notice that this guy has stolen my two first names, Robert Byron. One day when I was in the bookstore, aimlessly wandering around, which I often do, I just happened to see out of the corner of my eye on the spine of a book, Robert Byron. I thought, hey, who stole my name? And then it said the title of the book was The Road to Oxiana. I hadn't the flimsiest idea where Oxiana was. Well, it's the region of the Oxus River, which is between Afghanistan and Russia. And you can read this comment of a literary critic, Paul Fussell, and what this critic says leads you to the belief that this must be a really crazy book. And it is in many ways, except that there's also a bit of seriousness about it, because he really was interested in social sciences and architecture. He was educated at Oxford, but expelled because of rebellious behavior. Apparently he was always a bit goofy. He was best known for his impersonations of Queen Victoria. In the Middle East, he took this fabulous trip starting out in Palestine and going through Syria, Iraq, Persia, Afghanistan, and India. And if you look at the names of those cities, they're all cities that have been in the news for the last several years. He also visited Stalinist Russia and Hitler Germany, and he intensely despised both. He could not abide his countrymen, the English people, who actually were sympathetic to the Russian communists or sympathetic to the fascist sympathizers. So once again, he rebelled against the people that he was supposed to be working with. Unfortunately, he died when his ship to Cairo was sunk by the Germans. Too bad. Here's the trip that he took. You can see where he started out here in Palestine. Then he went up to Damascus and Beirut, over to Iran, Baghdad, Tehran, Isfahan, Shiraz, and then over here. And here's the Oxus River up here. But then he was traveling with a friend of his by car, not by a pack horse or anything that primitive, but he was actually there with a car with a friend of his from Cambridge University, or no, sorry, Oxford University. And but they couldn't get to the Oxiana River because there was some sort of quasi-military operation there. Well, I'm going to show you just a few of the pictures. Here's a picture from Afghanistan, And you'll notice the very elaborate Islamic architecture. Here's the next one is also the next one is from Iran, and this is the entrance to a mosque which has collapsed. And then the next one after that is a dome also in Iran. And here you can see some of the very intricate quotes probably from the Quran, written in the beautiful calligraphy of the Persian language. Sorry, of the Arabic language. Fantastic architecture. And then the next one is a picture of a tomb house. I think this is in Iran from the 6th century BC, so that's from well before the Islamic era. My final slide is this. Read. You can see that in the red letters. Now, I think you should read biographies or autobiographies. Read how people overcame their obstacles, like Dirac overcoming his terrible childhood. The second thing is you want to emulate the leaders in these fields, the people who really rose to the top because they did something unusual. The next thing is absorb ideas from your reading, because if you do that, ideas are very closely related to progress. If Wilbur and Orville hadn't had their ideas about how to make a glider stable, they never would have been able to fly. And another advantage of reading is the fact that you can develop your vocabulary. And if you can develop your vocabulary, you can become more effective in dealing with other people, you can become more persuasive, or you can become more inspiring. And those are all distinct advantages. I don't care what you read, but you're making a big mistake if when you get out of school, you don't really read. You really read a lot. I don't care whether you read about scientists, engineers, explorers, musicians. Why not read about the great composers, the great opera singers? These are fabulously interesting people. I don't know how many of you ever have read the book by Cal Giddings up at the University of Utah in the chem department. He wrote a book called Demon River Apurimac. That's about his kayak trip from up above Machu Picchu all the way down to the Amazon Valley. That's an incredible piece of writing. He was not only a very good chemist, he must have been a fantastic kayaker and certainly a brilliant writer. Well, I hope you've enjoyed this little detour into the art of reading. It's been a pleasure to be here, and you've been a very fine audience. Thank you.
We have a time for some questions. We do have 2 microphones that will be passed around, so just raise your hand if you have a question that you would like to ask Dr. Bird.
You may have to translate for me because I won't probably be able to hear.
Okay. Thank you for your coming here. I really enjoyed your lecture. I'm a university student here. I'm an undergraduate, and I'm majoring in chemical engineering. And I wondered if you would say something about how you think one can find the thing that they would be most passionate about pursuing in science.
Translate.
Yeah, so basically, What would cause someone to find?
What?
What would cause people to be passionate about something? What ideas would enable them to become passionate?
Or how to find that?
Why were they so passionate
Now,
about?
how would you develop being passionate about something, basically?
I still didn't quite understand.
How would you develop passion for something?
A passion for something? Well, I think you have to know enough about the subject to get passionate. How do you get to know enough about the subject? By reading, by studying. And if you read and study, then pretty soon you find yourself either being turned off by the subject or else you're getting caught by the subject and you develop a passionate interest that way. Did that answer your question, more or less?
Yes.
I'm sorry, I don't hear very well. In fact, I practically can't hear at all.
Bob, I really enjoyed that lecture. It was great. And I am wondering how long it took for you to write that book with your two co-authors, that masterpiece.
The
Transport
oh,
phenomena.
the transport.
Their
phenomena?
transport phenomena.
The first time we wrote it for the first edition, it took 3 years. The first year we turned out a preliminary edition in mimeograph form, which we shared with other universities. And then we got their criticisms. We took 2 more years and completely rewrote the book.
Were you working on it full time?
No, because I was teaching 3 courses at that time, and so were Ed and Warren.
Okay, thank you.
You're welcome.
Bob, you shared with us many examples of very talented people who were failed by universities, both faculty and students. Can you comment on why you think the universities didn't recognize their talents and help them to develop them, and what lessons that might have for universities today?
Okay, so why did the universities fail in recognizing the talents of many of these individuals?
Talents of whom?
Of many of these
Oh.
people that you talked about, the universities did not recognize their work and sometimes failed giving them professorships and things.
Well, in the case of Emmy Noether, it was because she was a woman, and they simply did not want women in the professorial ranks of the German universities. In the case of 2 of the people, they were Jewish and they were discriminated against by Hitler. I mean, Hitler simply kicked them out of the country. Who else haven't I covered? Of course, Dirac was pestered by George Batzler, which was a very tragic thing for Cambridge and also for Dirac.
You had a question on the students too, Larry?
Yeah, also the students that went there, many of them failed the university.
Yes.
Many of the students that you talked about as students never passed, in some cases, high school or university courses.
Yeah, so many of the individuals you talked about did not do very well in school and failed.
The fact that they didn't do well in school, well, might have been the fault of the schools, but also it was the fact that in the case of the Wright brothers, at that time, many people didn't finish high school. My grandfather started high school the same year that Wilbur did. And my grandfather stuck it out because he was having a wonderful time. And even when he was 90 years old, he could still recite the poems that he learned in high school. Great big long poems. And he could still speak German at age 90. Fantastic.
So what lessons may we learn from this, with them failing classes and yet still rising to great, doing great things? What lessons can we learn from that?
See, Who are we talking about?
Okay, so as far as these individuals that failed in school,
Yeah.
what kind of lessons can we learn based on how they were able to overcome their failures to become successful?
I guess that's kind of difficult to answer, isn't it? Let's see, who have we talked about that didn't finish school? The Wright brothers.
How about Charles Lindbergh, who failed the University of
Oh,
Wisconsin?
Charles Lindbergh, yes. Well, he was just a misfit in the College of Engineering. He was more interested in riding his motorcycle and in learning how to fly. And he had no interest in studying. So he came to the University of Wisconsin with his mother, and the two of them rented an apartment on the campus, and he went off riding his motorcycle, and his mother was studying, I think, French. Why he was that way? Well, I think the reason was probably that he came from a very dysfunctional family. Very dysfunctional. That makes a big difference. Just like Dirac's family was dysfunctional.
Great. An additional question?
Out of all the people that you studied, who do you admire most, or who is your hero?
Out of all of the individuals you studied, who was your hero?
Who was my hero? Oh my. I have lots of heroes. I've told you about some of them this evening, but I think there are many more. It's hard for me to remember now which one I would put at the top of the list. I've read quite a bit about composers and musicians, Beethoven, Brahms, Chopin, Rachmaninoff. I've enjoyed that very much. In many ways, they were heroes.
Great. Additional questions? Okay.
Sorry. Where did you come across the different biographies?
Where did you come across the different biographies?
Oh, you usually find them by talking to friends who also read. For example, in my department, there's Ed Lightfoot, and Ed Lightfoot is one of the most voracious readers that I know. And all through our career, he was telling me what he had read and why he was so excited about it. You can also get a great deal from reading the book reviews in the Wall Street Journal or in the New York Times or in various scientific magazines. For example, for physics, I read the book reviews in Physics Today every month because they usually steer you to some pretty good stuff. And I presume there are probably places in the chemical literature where you can go to get advice on biographies of chemists.
What has been the greatest challenge you have had in your professional life, and what's the greatest lesson you have learned?
What is the greatest challenge that you've had in your professional life?
The greatest one?
Challenge.
Challenge.
And what lessons have you learned from it?
Oh, that's a difficult question, isn't it? Well, one of the biggest disappointments I had was that I failed prelims. You know, the big exams you take before you get your doctor's degree. I failed them. And my major professor was furious with me. In fact, he didn't talk to me for about 3 months. I went around with my head bowed down. That was pretty hard to take, but it was a very good lesson for me because I found out that you shouldn't get too self-satisfied with what you're doing. And the reason I failed prelims was I went on a canoe trip when I should have been studying. The canoe trip was a lot of fun. But I didn't learn any chemistry on that.
Let's have one more question from the audience. Does anyone have one more question?
Dr. Bird, who was your favorite teacher in chemical engineering?
Who was your favorite teacher in chemical engineering?
My favorite teacher
Yes, in chemical engineering.
in chemical engineering. Well, let's see, I was an undergraduate chemical engineer, and at that time I was at the University of Maryland, and Joe Smith of the famous thermodynamics book and kinetics book was teaching at the University of Maryland. And he was a fantastic teacher. I really enjoyed his courses. Also, when I was in graduate school, Joe Hirschfelder, my professor, said, you want to learn some thermodynamics, but don't take the course in the chemistry department, don't take the course in the physics department, they're worthless. Go over to chemical engineering and take Olaf Haugen's course in thermodynamics. I've never regretted it. It was excellent.
Okay, so just in closing, what parting words would you like to give to everyone as we close here?
I think I've talked long enough.
All right. Please give I'd like to thank Dr. Bird for being here today. And again, if we could just give a round of applause for his time that he's taken.